This is video number 1 on the topic motion in a plane. First, let me discuss some basics. Motion means position of an object is changing. The simplest motion one can consider is motion along a straight line. For example, consider a straight road and there is a vehicle moving. This is the position at the initial time t0. At a later time, let it move here, and still later time t2 greater than t1, let it be there. So position of this object is changing, so we can say it's in motion. It's a straight line motion, so if I consider this as x-axis coinciding with the direction of motion, then the position of the object can be represented by one coordinate, which is x coordinate. Initially it's at x0, origin is somewhere here, this much is x0, from here to here is x1, and position of the object at instant t2 is x2, where x is the distance from here to that location at time t2. But instead of road being straight, realistically it could be like a curve. So a vehicle moving along this path, so initially it is here at t0, at t1 let it be here, and at t2 it's say here, and so on. So it's moving like this. So here the path of this body, it's not a straight line, it's a curve, but we can say that the body is moving in a plane with the earth's surface which is approximately flat. So here it is moving in the plane of the board. So for this motion, to specify the position, we need two coordinates. One is the horizontal direction coordinate x-axis and the vertical coordinate y-axis. So the initial location, if it over perpendicular, see this much is x0 and this vertical distance is y0. So the initial location is x0, y0. So at a later time, so this is x1 from the origin. The distance of this point is x1 and this vertical distance is y1. So the location of this point, it's x1, y1. So position of the vehicle at time t2 is x2, y2. So we need two coordinates to specify the position of the object moving in a plane. Timestamps are given in the description box. You can watch parts of video if running short of time. In this video, I will discuss what are scalars, what are vectors, which quantities should we consider as vector. A scalar is a quantity which has got only magnitude. For example, volume of an object. Here there is a glass with water and let the volume of this water be 100 ml. So this volume measure does not have any direction. It's just the amount of substance. So it's a scalar. Another example of scalar is mass of an object. Say have a 10 kg object. So this thing does not have any direction. If you have another object, say 5 kg, then the total mass of this object is 15 kg. So mass is also a scalar like volume. Now consider this situation where we have a book on a table. Suppose a force is applied from the left side then it will move towards right, where the force can overcome the friction. But if you reverse the direction of the force and apply in the opposite direction, say of same magnitude, then it will move in the opposite direction towards left. The force is same in the sense the magnitude of the force is same, say 5 Newton. This also 5 Newton. But the direction is different, so the outcome is different depending on the direction. So force is a vector because direction makes sense. If you apply a force vertically downwards, same 5 Newton, it will be at rest, it will not move. So if you apply a force in the inward direction, so it will move inside the book. And also if you apply a force, another possibility, if I apply the force in this outward direction, the book will come out of the plane of the book. So depending on the direction of the force, the outcome is different. So force is a vector. So if the direction of the force is down, the book will not move. If the direction of force is from the left, it will move towards right. From south, it will move in the north direction. Usually the right side is considered as east and this is west. So into the plane of the boat, let it be north direction, and coming outside, let it be south direction. So the force applied from south, it's inside the plane of the boat, then the boat will move inside in the north direction. So how to represent this scalars and vector? Scalar like mass, volume can be represented by corresponding appropriate alphabets, mass by m, volume by v. But a vector like force, to represent, use the alphabet, and to specify it's a vector, we put a direction, that's a arrow mark on the top. Or you can also just put, instead of arrow, just a bar on top. Or I can also make this alphabet boldface. This is especially the printed book. So P is also a pressure, and vector can be represented as a arrow. The direction of the arrow is the direction of the vector, and the length of the vector is proportional to the magnitude of the vector. For example, if this is 5 Newton, a force of 10 Newton in the same direction will be represented like this. Same direction is parallel to this one, but its length will be double of this one. So the length of the vector is proportional to the magnitude, and the direction is the direction of the vector. And magnitude of a vector is represented by this modular sign or just the alphabet. Vector is F with a bar, magnitude is you put the modular sign, or you just put this alphabet F. Scalar is just got magnitude, so it's a real number. So we can combine scalars like combining real numbers. We can add two scalars, subtract them, multiply them, divide them just like real numbers. Example of scalars are temperature, pressure, and so on. Vector, since the direction matters, for example, if I take this mass and apply a force, say 5 Newton, another force, 3 Newton. So this is equivalent to this mass applied the force of 8 Newton, same mass. Because since both the force in the same direction, the effects will add up. But instead, the second force is the first force, 5 Newton. The second force, 3 Newton, is applied in the opposite direction. Then both are opposing each other. So the effect will be difference of the two of 2 Newton. This is by common sense. So if the vectors are parallel in the same direction, we just have to add them up. If they are anti-parallel, then we have to subtract them. But what if the two forces are acting like this? Not in 0 degrees or 180 degrees, but in some arbitrary direction. So 5 Newton is acting horizontally, but 3 Newton is at an angle theta. Now how to add these two forces. So this way the vector law of addition comes, which will be discussed in the next video. Then we consider a simple example to appreciate the significance of direction. Move from point A to point B, which are separated by a distance of 10 meters. So point A, point B, distance is 10 meters. So if you consider this as origin, this is 0, and 10-meter point will be here. So if you move from A in the direction of B, 6 meters, so from A I'm moving. See, this is 6-meter position. So up to this point I'm moving. And then move 3 meters in opposite direction. So I'm turning back. And move in the opposite direction. So the distance from here to here is 3 meters. So this is the final position, starting with the initial position here. So the effective distance is this distance, which is 3 meters. This effective is actually displacement. But instead of moving 3 meters in the opposite direction, if I continue to move in the same direction, I would have reached here. Say final in the second case, which will be a distance of 9 meters from the initial position. So the effective distance covered, which is the displacement, depends on the direction of the motion. So direction matters for calculating the displacement. You can ask the doubts in the comment section.